Hello class, today we're on lesson 2, we're in chapter 4, and we're just going to cover absolute value and addition, and it's just really a brief overview of absolute values. There's really not a whole lot to this other than how to apply the absolute value, particularly to a negative. But let's read, in page 155 we read, as we see this Dow Jones Industrial cartoon, um, and I guess there's some imagery here, sort of like it going down, and they have these gentlemen, and I guess it has to do with it being negative, but they don't say if it's plus or minus, you'll notice, and he says you can't get more fiendish than that. Other than I guess there's an image of hell, so it must have been a negative. But anyway, let's go ahead and read. It says according to the minus, or excuse me, not to the minus, but according to the sign in this cartoon, the change in the Dow Jones Industrial Average was 24.04 points. If it had said plus 24.0, the market would have gone up. Negative 24.04 would indicate that the market had gone down. The sign in this cartoon, however, merely gives the amount of change. This change is also called the absolute value of change. A good way to picture the absolute value of a number is with the number line. It is simply the distance between the number and 0. The figure below shows that the absolute value of negative 24 and positive 24 are 24 0.0 or 0.04. Now let's take a look over here quickly, and we'll open up, get a marker here, and what we're just looking here is how we are able to indicate the value, whether it's positive or negative. So let's say we had the same thing. I don't have out to 24, but let's say I went all the way out to negative 3. So I have negative 3, and I also have positive 3. Okay, so regardless of whether we're going positive or negative, we know we have to jump over 3 either way. So the absolute value is measuring that. It's not telling you whether it's positive or negative. It's just saying that the value in this case we know was negative 3. Let's write that over here. And over here was positive 3. But in either case, we had to move 3. Okay, so the absolute value of negative 3 would be 3, and of course of positive 3 would also be 3. Now, let's continue reading. The symbol for absolute value looks like this as I drew. You have these two vertical bars, and then you can place your number, even expression, inside of it. The figure above shows that the absolute value of 24.04 is equal to 24.04, and the absolute value of positive 24.04 is 24.04. So whether we're going positive or negative, we just want to see the amount of change. And in this case, in the stock market, it dropped negative 24, which we know meant the value went down, but nonetheless, it went 24.04 from its original spot. Whenever we're dealing with a number in decimal form, we can always write its absolute value by dropping the plus or minus sign, as we have done above. However, we cannot write that the absolute value of a variable such as x by dropping the plus or minus sign because x itself has no sign. In this case, we must use the following algebraic definition of absolute value. It says if x is positive or 0, then the absolute value of x, and let's write that on our board here, the absolute value of x is equal to x, okay? If x is negative, then the absolute value of x is negative x. Now, it sounds confusing, and it says, well, that's completely different. Well, remember, we're taking the value of x and not necessarily the x, the actual sign. So we're always taking the x. So in fact, this would actually look more like this, negative absolute value of x. So we'll discuss this a little further as we go through, but just note that when we're dealing with variables, it's not always the same as when we're dealing with an actual number, because the number in itself is defined. X in itself doesn't really have a positive or negative. In fact, you can, in a sense, put a positive or negative into X, but the variable itself does not have an actual sign. So the idea of absolute value is helpful in extending our knowledge of how to compute with the positive and negative numbers that are integers to other numbers as well. In this lesson, we will learn how it applies to the addition of rational numbers. To add positive negative numbers, we use particle-antiparticle model. To extend this idea to adding rational numbers, we can think in terms of lengths and anti-lengths instead. And here are some examples. Colors are used, or a color is used in the diagrams to represent anti-length. So we have here example number 1 where we see 1.2 as a length and we're adding 5.3 and we're totaling that to be 6.5 and they're just putting the lengths together. Now we also have the second example where they're negative, negative 3, so it's green, negative 2.4. When you add them together, you have negative 5.4. But notice what they're doing in example 3 where they have 4.5 and negative 6. So they put them side by side, and the sum of 4.5 and negative 6 turns out to be negative 1.5, which is kind of what's left over here because we know that the 4.5 is canceling out. And we've gone over this with numbers. Number lines aren't how we're going to calculate, so I'm not going to spend a whole lot of time showing you how this works in a number line, but it's a good illustration to show you how we cancel out the numbers. So for instance, when we have, say, a negative 13 and a positive 10, right, plus 10, we said, well, let's look at this as negative 13, oh, excuse me, negative 10 plus negative 3, right? And why are we doing this? Well, it's going to allow us to cancel out the positive 10 over here, which leaves us with negative 3. So they're just using this, again, just as a visual example. Now, there's a limitation to this in its application, so we won't spend too much time on this, okay? Now, when we look at example 4, it says, what is the sum of negative 1.8 and positive 4.8? And again, simply they're using this annihilation word. They're just offsetting. I like to use the word more of offsetting because that's generally what we're doing with numbers. Now, let's read. From examples 1 and 2, we see the sum of two positive numbers is the positive number given by the sum of their lengths, and the sum of two negative numbers is the negative number given by the number of their anti-lengths. And here's that wonderful long description that I promised you of how to add. And again, I don't want you to have to memorize this. I want you to be able to just do this in your head. In terms of the absolute value, this means that the sum of two numbers having the same sign can be found by adding their absolute values and the answer having the same sign as numbers. And if we read from examples 3 and 4, we see when a positive and negative number are added, the one that has a shorter length or anti-length is annihilated, or offset as I used, leaving as the answer the rest of the number that has the longer length or anti-length. This means that the sum of two numbers having opposite signs can be found by subtracting their absolute values, the answer having the same sign as the number having the larger value. So, I mean, we were looking at that here. This has the larger value in a sense. It's higher, has more of an impact, negative 13. So we know our answer is going to be negative. And that's kind of what they're trying to show you, but using absolute values. And then they have another illustration here where they're adding 1.5 and negative 7.6. So really, I just wanted to cover the chapter. You can go ahead and do the work. If there's any questions, by all means, do contact me.